Hello everyone, welcome to Creative Civil Engineering Coach. In this video, I'll be discussing about PGCET 2021 Civil Engineering question paper, which was held on 13 November 2021. So let's begin with the part 1 questions. Question number 1. Negative skin friction on piles is. So in the following figure, you can observe the negative skin friction act downwards and decreases the load carrying capacity of the file. So option C is the right answer. Question number 2. When the retaining wall moves away from the backfill, the pressure exerted on the wall is termed as. Since the weight of the backfill is responsible for the movement of the retaining wall, the pressure exerted on the wall is termed as active earth pressure. Option D is the right answer. Question number 3. Compaction by vibratory roller is the best method of compaction in case of. So, vibratory roller compaction is used for well-graded dry sand. Option B is the right answer. This well-graded dry sand is also called as cohesionless soil or sand, considered at a suitable depth. Question number 4. The factor of safety for retaining walls against overturning for cohesive backfill is. So as per IS 1904-1986 from the clause 17.1, the factor of safety for retaining walls against overturning for a cohesive backfill is taken as 1.5. Option A is the right answer. Question number 5. Road roughness is measured using. Road roughness is measured using bump integrator. Option B is the right answer. Question number 6. The terrain may be classified as rolling terrain if the cross slope is. When the cross slope is between 0 to 10%, it is termed as plain terrain. And when the cross slope is between 10 to 25%, it is termed as rolling terrain. And when the cross slope is between 25 to 60%, it is termed as mountainous terrain. And if the cross slope is greater than 60%, the terrain is classified as steep terrain. So according to the question, for a rolling terrain, the cross slope should be between 10 to 25%. Option B is the right answer. Question number 7. If due to some practical reasons, if there is no friction between the wheels, then this will result in a situation where, since the coefficient of friction is 0, the maximum super elevation will be V square by GR, where V is the design speed of the vehicle, G is the acceleration due to gravity, and R is the radius of horizontal curve. Therefore, the pressure on the outer wheel will be equal to the pressure on inner wheel. Option C is the right answer. Question number 8. For the design of super elevation for a mixed traffic condition, the speed is reduced by. As per IRC, the centrifugal force corresponding to 75% of the design speed is counteracted by providing the super elevation on horizontal curve. So, the maximum rate of the super elevation will be V square divided by 225R. So, the speed of the vehicle will be reduced by 100 minus 75%, which is equal to 25%. So, option B is the right answer, 25%. Question number 9. The penetration test on bitumen is used for determining its. Penetration test is carried out to know the hardness or softness of the bitumen used in the road construction by measuring in distance in tenths of a millimeters, to which a standard needle will penetrate vertically into a sample of bitumen under stipulated condition of temperature, time and loading. So for example, hardest grade of a bitumen in terms of 30 to 40 penetration value, which means that it is only about 3 to 4 mm, which is taken in tenths of a millimeter. So the penetration test on bitumen represents its grade value. Option A is the right answer. Question number 10. The sleeper density formula M plus X, X does not vary according to which of the following factors? As per IRC, sleeper density is calculated by the general formula M plus X, where M is the gauge length of the railway track, such as broad gauge, meter gauge or narrow gauge, and X depends upon the several factors such as type and section of the rails, type of the ballast cushion and the axial load. All these factors depend on the X values, but the slope of the track does not depend on X value. So option D is the right answer, slope of the track. Question number 11. How is the lateral displacement of the rail is balanced? The lateral displacement of the rail causes huge bending moment in the wheels, and this huge bending moment is balanced by the friction between the rail and the sleepers and the opposition which is offered by the fastenings. So the right answer will be option B, friction between the rails and sleepers. Question number 12. Which of the following lining material is useful for shield driven tunnels in subaqueous region? Shield driven tunnels are majorly found in urban areas where the best lining material would be cast iron. Option C is the right answer. Question number 13. Which one of the following tunneling methods is used for laying underground sewer? In the following figure, you can observe the laying of underground sewer, which was advised by US Army for constructing small tunnels at reasonably shallow depth. So it is the Army method. It is also called as case methods. This was mainly used for laying underground sewer. So option B is the right answer. Question number 14. At a place the shoreline is along northwest southeast, the wind is blowing from the north. The littoral drift will be along. So when the wind is blowing from the north, the littoral drift will be acting along its opposite direction. So it will be in southeast direction. Option A is the right answer. Question number 15. Metros and monorails in India uses. In India, we use standard gauge of a length 1.435 meter for both metros and monorails. So option C is the right answer. Where you can observe the speed of the metros will be much faster than monorails, because in metros we use 2 rails and in monorails we use 1 rail. Question number 16. The nominal size of ballast used for points and crossing is. Ballast sections are used to hold the sleepers and convert live load to uniformly distributed load. So as per IRC, the nominal size of the ballast section for points and crossings should be 25 mm. Option A is the right answer. And suppose if the wooden sleepers are used, the size of the ballast would be 50 mm. And in case of metal sleepers, the size of the ballast would be 40 mm. Question number 17. The standard length of rail for broad gauge and meter gauge are respectively. So as per IRC, for a broad gauge, the rail length is 12.8 meter, and for meter gauge, it was 11.89 meter. But now it is standardized for 13 meter and 12 meter. So the right answer is option C. Question number 18. For ensuring quality of the concrete, we use graded aggregates. Option C is the right answer. Because if the different size and shape of the aggregates are mixed together in concrete, there will be stronger bonding action. Question number 19. Under normal conditions using ordinary cement, the period of removal of formwork is. In the following table, you can observe the minimum requirement of period for the removal of formwork. So in case of soffit, it is 7 days, and in case of a slab spanning 4.6 meter and above, it is 14 days, and for the beam spanning more than 6 meter, it is 21 days. So all these options are right. So the correct answer is option D. Question number 20. The process of proper and accurate measurement of concrete ingredients for uniformity of proportion is grading. Option A is the right answer. Question number 21. Pick up the correct statement from the following. So here they have given about the tricalcium silicate, which is a Bogue compound of a cement. So the property of the tricalcium silicate has more resistance for sulfate attack. Option D is the right answer. Question number 22. The commercial name of white and colored cement in India is. So the commercial name is also called as Colocrete, Silvicrete and Snowsen. All these options are correct. So the right answer is option D. Question number 23. As compared to ordinary Portland cement, high alumina cement has. So in these given options, it is the property regarding the initial setting time and final setting time. So for ordinary Portland cement, initial setting time will be 30 minutes and final setting time will be 10 hours. But for high alumina cement, the initial setting time will be 3.5 hours, where the final setting time will be 5 hours. So by comparing these initial and final setting time values, we can conclude The high alumina cement has higher initial setting time, that is 3.5 hours, but lower final setting time of 5 hours compared to ordinary Portland cement. So the right answer is option A. Question number 24. Which type of the roof are preferred for public building like libraries and theatres? So for construction of libraries and theatres, the best roof adopted is curved roofs. So the main purpose of adopting the curved roof is aesthetic appearance more than its durability. So the right answer will be option D. In the following figure, you can observe the type of curved roof where the slope provided gives a flat metal a distinct and modern appearance and promotes the architectural details. So the right answer will be option D. Question number 25. Which of the following roof slopes in two opposite direction? When the roof slopes in two opposite direction, it is called as gable roof. So option B is the right answer. In the following figure, you can observe the different types of the roof sloping in different directions. So if it is sloped in one direction, such type of roof is called lean-to roof, and if it is sloped in four directions, such type of roof is called mansard roof. And if all the roof sides slope downwards in a square type, where the wall of the house sit under eaves of the each side of the roof, such type of the roofs are called hip roof. Question number 26. A stair turning through two right angles is known as dogleg stair. Option D is the right answer. If the wall or column under construction is nearer some other property, it will not be possible to spread the footing to both the sides of the wall or column. In such cases, which type of the footing is preferred? In the following figure, you can observe this is the property line of the given boundary area, which restrict to spread the footing to both sides of the wall or column. In such cases, the type of the footing adopted will be eccentric type of footing. Option B is the right answer. The eccentric type of footing will be designed in such a way that center of gravity of the superimposed load coincides with the center of gravity of base area, resulting in uniform bearing pressure. So right answer will be option B. Question number 28. The pitch of a stair should be limited to. So in a staircase, you can observe here, this is tread and this is riser, and this is the angle between the riser and tread, which is called as pitch angle. It is the angle at which the line of nosing of staircase makes with a horizontal. So this pitch angle should be limited to 30 to 45 degree. Option C is the right answer. Question number 29. The combination of king post and queen post trusses are suitable to a span of less than 18 meter. Option A is the right answer. Question number 30. The type of the survey in which the curvature of earth is taken into account is called geodetic survey. Option A is the right answer. So in this type of the survey, the limit of survey should be greater than 250 km square. Question number 31. For setting out right angles, the instrument used is optical square. Option A is the right answer. Question number 32. Which of the following sides will be applicable while changing the point? When there is a change in point, the sides taken in a ground is back side and foresight. Option D is the right answer. Question number 33. In a quadrantal bearing system, the bearing of a line varies between 0 to 90 degree. Option C is the right answer. So for a quadrantal bearing system, the type of the bearing lies between 0 to 90 degree, and in case of a whole circle bearing, the bearing line ranges between 0 to 360 degree. Question number 34. A 30 meter metric chain is found to be too short throughout a measurement. If the distance measured is recorded as 300 meter, what is the actual distance? In this question, you can observe the too short distance is missing. So there is an error in this question. It was expected to be given as 10 cm too short. Assuming this value, let us find the actual distance. So actual distance will be 30 meter minus 0.1 meter divided by 30 meter into measured distance is 300 meter. So the actual distance will be 299 meter. So option C is the right answer. Question number 35. Theory of errors and adjustments deals with minimizing the effects of personal and accidental errors. Option D is the right answer. Question number 36. The survey carried out to delineate natural features such as rivers, forest, and man-made features such as towns, buildings, roads, transmission lines, and canal is classified as topographical survey. Option D is the right answer. Question number 37. The magnetic declination at a place if the magnetic bearing of a sun at noon is 184 degree. We know that true bearing of a line is equal to magnetic bearing plus declination. True bearing is 180 degree. Magnetic bearing is given as 184 degree. So its declination will be 180 minus 184 degree, which is equal to minus 4 degree, which means that declination is 4 degree west, because declination, if it is negative, it will be on western side, and suppose if the declination is positive, it will be on eastern side. Since the declination is negative, it will be 4 degree west. Option B is the right answer. Question number 38. Contour lines of different elevation can unite to form one line only in case of vertical cliff. Option C is the right answer. In the following figure, you can observe the vertical cliff. Question number 39. The formula used to calculate area of a figure using planimeter is. When we calculate the area using a planimeter, the formula we use is A is equal to m into f minus I plus or minus 10n plus c, where m is the multiplying constant, f and I are the final and initial readings, n is the number of times of 0 of dial pass in the index mark, c is the constant marked above the scale division in tracing arm. So the right answer will be option B. Question number 40. The apparent movement of an image with respect to crosshair is parallax. Option B is the right answer. Parallax is the displacement of difference in the apparent position of an object viewed along two different lines of sight, and it is measured by angle or semi-angle of inclination between those two lines. Question number 41. The first order measurements are used in triangulation survey. Option C is the right answer. Question number 42. The effective stress friction angle of a saturated cohesionless soil is 38 degree. The ratio of shear stress to normal effective stress on the failure plane is. We know that the ratio of shear stress to normal stress is equal to tan of friction angle. Since the angle of friction is given as 38 degree, the ratio of shear stress to normal stress will be tan of 38 degree. Therefore, the required ratio will be 0.781. So option A is the right answer. Question number 43. As per IS soil classification system, the sample of silty clay with liquid limit of 40% and plasticity index of 28% is classified as. Liquid limit is given as 40%, plasticity index of silty clay is given as 28%. So to decide the type of the silty clay, we have to calculate the equation of A line, which is given by the formula 0.73 times of liquid limit minus 20. So 0.73 times of liquid limit is given as 40%, so 40 minus 20. So equation of A line will be 14.6%. Since the equation of A line is less than plasticity index of a silty clay, the type of the clay will be intermediate clay. Option B is the right answer. Question number 44. In a soil specimen, 70% of the particles are passing through 4.75 mm IS sieve and 40% of the particles are passing through 75 micron sieve. Its uniformity coefficient is 8 and coefficient of curvature is 2. As per IS classification, this soil is classified as. Coefficient of uniformity is given as 8, coefficient of curvature is given as 2, percentage of particles passing through 4.75 mm IS sieve is 70%, and percentage of particles passing through 75 mm sieve is 40%. Since the percentage of the particles passing through 4.75 mm is greater than 50%, it will be classified as sand, and for a well graded soil or sand, the coefficient of uniformity should be greater than 6, and if the coefficient of curvature is between 1 to 3, such type of the soil is classified as well graded soil. So the right answer will be well graded sand. It is option C. Question number 45. The following soils are compacted at the same compact effort in the field. Which one of the following is the correct sequence in increasing order of their maximum dry density? We know that fine soils has a lower maximum dry density. Clay is an example for lower maximum dry density soil, and clay mixture is a well graded soil which has higher maximum dry density. So the correct increasing order of sequence is clay, silty clay, sand, gravel sand and clay mixture. Option C is the right answer. Question number 46. Allowable bearing pressure for a foundation depends upon both allowable settlement and ultimate bearing capacity. Option C is the right answer. Question number 47. The rise of water table in the cohesionless soil up to the ground surface reduces the net ultimate bearing capacity approximately by. The reduction factor for a cohesionless soil will be 0.5 times of 1 plus vertical depth Z divided by depth of the footing. So for a cohesionless soil, vertical depth will be 0. So the reduction factor will be 0.5 into 1 plus 0 by depth of footing. So it will be around 50% reduction. So the correct answer will be option B, 50%. Question number 48. A square footing is proportioned on a cohesionless soil with an average N values of 40. The allowable bearing pressure of this footing will be given by. The allowable bearing pressure when it is proportioned on a cohesionless soil with an average N value greater than 30 and angle of internal friction greater than 36 degree, it undergoes a general shear failure. Option A is the right answer, general shear failure. In this type of the shear failures, it has a well-defined failure pattern. Question number 49. The minimum bearing capacity of a soil under a given footing occurs when the groundwater table at the location is at ground level. Option B is the right answer. So, if the groundwater table at the location is at ground level, it reduces the minimum bearing capacity to its half of its initial value, since the soil will be in submerged condition. Question number 50. The soil pressure distribution below a rigid footing on a surface of cohesive soil is. In the following figure, you can observe a rigid footing on the surface of cohesive soil where the maximum pressure distribution will be at edges and minimum pressure distribution will be on center of rigid footing. So right answer will be option B, minimum at the center and maximum at the edges. So this completes the part 1 questions of this question paper. Now let's begin with part 2 questions. Question number 51. A 2-lane urban road with a one-way traffic has a maximum capacity of 1800 vehicles per hour during a peak hour. The average length occupied by the vehicle is 5 meters. The speed versus density relationship is linear for a traffic volume of 1000 vehicles per hour. The density in vehicles per kilometer will be. So these are the given data. 2-lane maximum capacity is 1800 vehicles per hour and its space headway is 5 meters. Therefore, jam density will be 1000 divided by space headway means 1000 divided by 5, which is equal to 200 vehicles per hour. So for one lane capacity, Q max will be 1800 divided by 2, which is equal to 900 vehicles per hour. We know that maximum flow Q max is equal to jam density into free mean velocity of the vehicle divided by 4. If you calculate this, you will get the free mean velocity of the vehicle as 18 km per hour. Now for one lane flow, Q will be 1000 divided by 2, which is equal to 500 vehicles per hour. Therefore, on substituting this, U is equal to 18 minus 18 divided by 200 vehicles per hour into density of the vehicles. The density will be 33.32 vehicle per kilometer. So it is required to calculate for 2-lane capacity. So the density of the vehicles will be 2 times of 33.32 vehicle per kilometer. So it is 66.64 vehicle per kilometer. Option C is the right answer, 67. Question number 52. The design speed of national highway is 100 km per hour if the maximum permissible super elevation is 0.1 and the coefficient of lateral friction is 0.15. The minimum ruling radius of the horizontal curve on the highway should be. We know that as per IRC, E plus F is equal to V square divided by 127R. On substituting the values of maximum super elevation and coefficient of lateral friction, 0.1 plus 0.15 is equal to V is the design speed of the vehicle. So the radius of horizontal curve will be 314.96 meter. Option B is the right answer. Question number 53. A road is having a horizontal curve of radius 400 meter on which a super elevation is 0.07 is provided. The coefficient of lateral friction mobilized on the curve when a vehicle is traveling at a speed of 1100 km per hour is. So we have to determine the value of coefficient of lateral friction. As per IRC, we know that E plus F is equal to V square divided by 127R. Substituting the given values, that is maximum rate of super elevation and design speed of the vehicle and radius of horizontal curve, the coefficient of lateral friction will be 0.130. So in these following options, you can observe here the coefficient of lateral friction in the option B, it must be 0.13. So there was a printing mistake and it was expected to give grace marks for this question. Question number 54. The free mean speed on a roadway is found to be 800 km per hour under stopped condition. The average spacing between the vehicles is 6.9 meter. Determine the capacity flow. In this question, you can observe the free mean speed is given as 800 km per hour instead of 80 km per hour. So this was expected to give grace marks for this question. So considering free mean speed as 80 km per hour, the capacity of the flow will be free mean speed multiplied by jam density divided by 4. Free mean speed is given as 80 km per hour and the jam density, that is maximum density at zero speed, is 1000 divided by S. S is the space headway, which is given as 6.9 meter. So on substituting the given values, that is free mean speed as 80 km per hour multiplied by 1000 divided by 6.9 divided by 4. Therefore, the capacity flow will be 2898.55, which is equal to 2900 vehicles per hour per lane. So option A is the right answer, 2900 vehicles per hour per lane. Question number 55. The ascending gradient of 1 in 100 meets a descending gradient of 1 in 120. A summit curve is to be designed for a design speed of 80 km per hour so as to have an overtaking side distance of. So we have to determine the length of the summit curve. In this question, you can observe the OST distance is not given. So it was expected to give overtaking side distance as 470 meter. So assuming the length of summit curve greater than overtaking side distance, length of the summit curve will be, so n is the rate of change in gradient, that is ascending to descending gradient. So 1 by 100 minus of minus 1 by 120, it will be 0.01833. Overtaking side distance is 470 meter. Substituting these values, the length of the summit curve will be 421.85 meter. So option A is the right answer. Since they have not given the overtaking side distance, this was expected to give a grace marks for this question. Question number 56. A train weighing 3000 tons is moving on a flat territory on a curve of 20, whose length is more than length of the train. What is the maximum curve resistance of the train? Calculate the equivalent grade of the resistance. In this question, the degree of the curve is given as 20 instead of 2 degree. It was expected to give the degree of curve as 2 degree. There was a printing mistake. So for this question, it was expected to give a grace marks. Assuming the value of degree of curve as 2 degree, let us calculate the curve resistance, which is given by the formula 0.4 into degree of the curve into train weight. Substituting the given values, the curve resistance will be 2.4 tons. Now let's calculate the equivalent grade, which is given by the ratio of curve resistance divided by the weight of the train. Curve resistance, as we have calculated earlier, it is 2.4 tons. So 2.4 tons divided by weight of the train is given as 3000 tons. So the equivalent grade will be 1 in 1250. So the correct answer is option A. 2.4 tons is the curve resistance and its equivalent grade is 1 in 1250. So option A is the right answer. Question number 57. A valley curve is formed by a descending gradient of 1 in 25 meeting an ascending gradient of 1 in 30. Design the length of valley curve to fulfill both comfort condition and headlight distance requirements for a design speed of 80 km per hour. Assume the allowable rate of change of centrifugal acceleration c is equal to 0.6 meter per second cube. There is a printing mistake. C should be given as 0.6 meter cube per second. So we have to determine the length of valley curve based on comfort condition and headlight distance requirements. So as per IRC, based on the comfort condition, the length of the valley curve is calculated by the formula 2 times of nv cube divided by c to the power of 1 by 2, where n is the deviation angle, v is the design speed of the vehicle, c is the rate of change of centrifugal acceleration. Design speed should be calculated in terms of meter per second. So we shall convert the given design speed in kilometer per hour to meter per second as 22.24 meter per second. Deviation angle is rate of change of gradient, that is from ascending to descending gradient. So the deviation angle will be 0.073. Rate of change of centrifugal acceleration is given as 0.6 meter cube per second. Substituting these values, the length of valley curve will be 73.1 meter. Now the next condition is based on headlight side distance. It is given by the formula L is equal to ns square divided by 2 into h1 plus 2s tan alpha. Assuming the length of valley curve should be greater than safe stopping side distance. So first we shall find out the safe stopping side distance by the formula Vt plus V square by 2gf. So here the value of reaction time and the coefficient of lateral friction and acceleration due to gravity, these are all assumption. On substituting these value, the safe stopping side distance will be 127.628 meter. So the length of valley curve L is equal to ns square divided by 2 into h1 plus 2s tan alpha, where s is the safe stopping side distance, n is the deviation angle, h1 is the average height of the headlight, that is 0.75 meter. This is the standard value. This is assumption. And alpha is the beam angle of headlight, that is 1 degree. This is also assumption. Assuming these value, the length of the valley curve based on the headlight side requirements, it will be 199.6 meter. So the correct answer will be, based on the comfort condition it is 73.1 meter, and based on the headlight side distance it is 199.5 meter. So option C is the right answer. Question number 58. The length of transition curve of a radius 300 meter and for a design speed of 15 meter per second square is. Design speed of the vehicle is given in meter per second. There is a printing mistake. It was given as meter per second square. So before calculating the transition curve, here you can observe the rate of change of centrifugal acceleration is not given. So for this question it was expected to give a grace marks since they have not given the rate of change of centrifugal acceleration. So assuming the value of c is equal to 0.3 meter cube per second, length of the transition curve Ls is equal to 15 cube divided by 0.3 into 300. So 37.5 meter will be the length of transition curve. Option B is the right answer. Since question number 59, the magnetic bearing of a line AB is south 450 east. It was supposed to give as 45 degree east and the declination is 50 west. This was supposed to be as 5 degree west, and the true bearing of the line AB is, so we have to find the true bearing. We know that true bearing is equal to magnetic bearing plus or minus declination. Since there is a printing mistake, assuming the value of bearing of a line as 45 degree east, south 45 degree east and the declination of 5 degree east, let us calculate the true bearing. So true bearing is equal to magnetic bearing minus declination. Since the magnetic declination is given in the western side, assuming it as negative, true bearing will be 45 degree minus 5 degree. So it will be south 40 degree east. Option B is the right answer. Question number 60. The contour interval on a map is 15 meter. If the upward gradient is 1 in 20 is required to drawn between the two parts, the horizontal equivalent between the 2 points A and B will be. Horizontal equivalent between the 2 points is calculated by the ratio of contour interval divided by gradient. So contour interval is given as 15 meter and its upward gradient is given as 1 in 20. So if you calculate this, the horizontal equivalent between the 2 points A and B will be 300 meter. So option B is the right answer. Question number 61. Which of the following scale is smallest and largest respectively among these following options? When the representative fraction of the scale is smaller, then its scale will be largest. And if the representative fraction of the scale is larger, then its scale will be smallest. So the representative fractions for statement 1 is 1 into 10 to the power of minus 3. For option 2, it is 1:10,000, and the representative fraction for option 3 is 1 by 10,000, and the representative fraction for option 4 is 1 into 10 to the power of minus 8. So if you observe these representative fraction of the given options, the smallest scale is option D, that is 1 into 10 to the power of minus 8, and the largest scale is 1 into 10 to the power of minus 3. So option D is the right answer. 4 and 1. Question number 62. The length of the survey line was measured with a tape having a nominal length of 20 meter and was found to be 236.4 meter. As a check, the length was again measured with a 30 meter tape and was found to be 240.5 meter. So on testing, it was found that 20 meter tape is 6 cm too short. What is the true length of 30 meter tape? So for the first condition, when the length is measured by 20 meter tape length, incorrect length of the line is 20 minus 0.06, that is 6 meter too short. So 6 divided by 100. So it is 20 minus 0.06 divided by 20 meter into measured length is 236.4 meter when it is measured by 20 meter tape. So the incorrect length will be 235.6 meter. So for the second condition, when it is measured by 30 meter tape, actual length of 30 meter tape will be 235.6 meter divided by 240.5 meter into 30 meter. So actual length of 30 meter tape will be 29.40 meter. So the true length of the 30 meter tape will be 29.40 meter minus 30 meter, which is equal to minus 0.60 meter, which means that it is 60 centimeter short. Option B is the right answer. Question number 63. The chain edge of intersection point of two straight is 1585 meter and the angle of intersection is 1400. This was expected to give as 140 degree. If the radius of circular curve is 600 meter, the tangent distance in meters and the length of the curve in meters respectively are. So let's first find out the tangent length, which is given by the formula T is equal to R tan delta by 2, where delta is the deflection angle. Here they have given the angle of intersection. So to find the deflection angle, it is 180 minus angle of intersection. So 180 minus 140 degree. So the deflection angle will be 40 degree. Substituting the value of deflection angle, tangent length will be 600 into tan 40 divided by 2. So tangent length will be 218.38 meter. Now let us find the length of curve. Length of the curve is calculated by the formula pi r delta by 180, where r is the radius of circular curve, delta is the deflection angle. So pi into 600 into 40 divided by 180. So length of the curve will be 418.8 meter. So the correct answer is option C. Question number 64. A tall tower was photographed from an elevation of 700 meter above the datum. The radial distance of top and bottom of the tower from the principal points are 112.5 mm and 82.48 mm respectively. If the bottom of the tower is at an elevation of 250 meter above the datum, then the height of the tower is, so we have to calculate the height of the tower. In the following figure you can observe the tower bottom is placed 250 meter above the bottom and the total elevation from the datum is 700 meter. So here you can observe these are the radial distance which are measured from the top and bottom of the tower. So R1 is equal to 112.5 mm, which is measured from the top of the tower, and R2 is the radial distance which is measured from the bottom of the tower, that is 82.48 mm. So relief displacement D is equal to difference between the radial distance, so it is 112.5 mm minus 82.48 mm, which is equal to 30.02 mm. We know that the relation between the relief displacement and the height of the tower is relief displacement D is equal to H into R1 divided by H minus H average. Relief displacement is calculated as 30.02. H is the height of the tower we have to calculate. R1 is the radial distance which is measured from the top of the tower, so 112.5 mm, divided by H is the total height of the elevation, so 700 meter, minus H average. So H average is the bottom of the tower above datum, which is given as 250 meter. On solving this, the height of the tower will be 120.4 mm. So the right answer is option A, 120.4 mm. Question number 65. The reduced bearing of a 10 meter long line is north 300 east. It was expected to give as north 30 degree east. There is a printing mistake in this question. The departure of the line is, we know that departure D is equal to L sin theta. So L is the 10 meter long line, so 10 into sin 30 degree. So departure will be 5 meter. Option D is the right answer. Question number 66. The perpendicular offset were taken at a 10 meter interval from a survey line to an irregular boundary line are as follows. These are the perpendicular offsets. The area enclosed between the survey line and the irregular boundary line by using Simpson rule will be. So according to Simpson rule, the area is calculated by the following formula, that is A is equal to D by 3 into Y0 plus Yn plus 2 times of even ordinates plus 4 times of odd ordinates, where D is the contour interval which is given as 10 meter, Y0 is the first perpendicular offset and Yn is the last perpendicular offset. So Y0 is 3.25 meter and Yn is last perpendicular offset 5.65 meter. Calculating the even ordinate sum, that is Y2 plus Y4 plus Y6, the sum of even ordinates is 16.2 meter and the sum of odd ordinates is Y1 plus Y3 plus Y5 plus Y7. So sum of odd ordinates is 22.6 meter. Therefore, substituting this value, the area of the irregular boundary will be 10 by 3 into 3.25 plus 5.65 is the sum of first ordinate and last ordinate plus 2 times of sum of even ordinates, that is 16.2 meter, plus 4 times of sum of odd ordinates, that is 22.6 meter. On solving this, the area of the irregular boundary is 439 meter square. So to convert it into acres, it will be 439 multiplied by 10 to the power of 4 into 10 to the power of minus 6. So area will be 4.39 acres. So option B is the right answer, 4.4 acres. Question number 67. The total settlement of a compressible soil stratum 2 meter deep and having a coefficient of volume compressibility as 0.025 centimeter square per kg is. Total settlement of a compressible soil is calculated by the formula depth of the soil stratum multiplied by coefficient of volume compressibility multiplied by change in pressure. In this question, they are not given a change in pressure, so this was expected to give a grace marks for this. So it was expected to give change in pressure as 2 kg per centimeter square. So assuming this value, let us calculate the total settlement of a compressible soil. It is 200 is the depth of the soil stratum, 0.025 is the coefficient of volume compressibility, and 2 kg per centimeter square is the change in pressure. This value is not given. Assuming this value, the total settlement of a compressible soil stratum will be 10 cm. Option D is the right answer. Question number 68. The natural water ratio of a saturated clay state 3 meter thick is 0.90. The final water ratio of the clay at the end of consolidation is expected to be 0.710. The total consolidation settlement of a clay strata is. So we have to find the total consolidation settlement. We know that the relation between the change in water ratio and total settlement is given as delta H is equal to H into change in water ratio divided by 1 plus initial water ratio. So substituting the value of clay state thickness, that is 3 meter, change in water ratio is difference between the initial and final water ratio, that is 0.90 minus 0.710 divided by 1 plus E0. E0 is the initial water ratio, so 1 plus 0.90. On calculating this, the total consolidation settlement of the clay strata will be 30 cm. Option A is the right answer. Question number 69. If a soil sample weight of 0.18 kg having a volume of 10 to the power of minus 4 meter cube and the dry unit weight of 1600 kg per meter cube is mixed with a 0.02 kg of water, then the water content in the soil sample will be. So we have to find the water content of the soil sample. So let's first find the dry weight of the sample, which is the product of dry unit weight multiplied by its corresponding volume. So the dry weight of the sample will be 0.16 kg. Now we shall find the weight of the water before mixing. Weight of the water before mixing is difference between the weight of the soil sample minus dry weight of the sample. So it is 0.18 kg minus 0.16 kg. So the weight of water before mixing will be 0.02 kg. Now the total quantity of the water will be sum of the weight of the water plus weight of the water before mixing. So it is 0.04 kg of water. Therefore the water content of the soil sample will be the ratio of total quantity of the water 0.04 kg divided by dry weight of the sample 0.16 kg. So it is about 25%. Option B is the right answer. Question number 17. The total active thrust on a vertical wall 3 meter high retaining a horizontal sand backfill with a unit weight of 20 kN per meter cube, angle of shearing resistance of phi is equal to 30 degree when the water table is at bottom of the wall will be. So we have to find the total active thrust, which is given by the formula half times of coefficient of active pressure multiplied by its unit weight multiplied by its square of its total height of the retaining wall. Height of the retaining wall is given as 3 meter. Unit weight is given as 20 kN per meter cube. Coefficient of active earth pressure is 1 by 3. On substituting this value, the total active thrust will be 30 kN meter. Option A is the right answer. Question number 71. Two footings, one circular and other square, are founded on the surface of purely cohesionless soil. The dia of the circular footing is same as that of one side of the square footing. The ratio of their ultimate bearing capacity is. So we have to find the ratio of ultimate bearing capacity of circular footing divided by ultimate bearing capacity of square footing. We know that ultimate bearing capacity for circular and square footing is given by this following formula. In the given question, it is mentioned that foundation is laid on ground, that is, depth of the footing will be 0, and the soil type is given as cohesionless, so the value of C is 0. So the required ratio of ultimate bearing capacity will be 3 by 4. Option A is the right answer. Question number 72. The observed value of standard penetration number n at a 10 meter depth for a silty sand deposit is 13. The unit weight of the soil is 16 kN per meter cube. The n value after correcting for pressure fineness will be. So let's first apply the overburden pressure correction, which is given by the formula n1 is equal to n0 into 350 divided by sigma, where sigma is the effective overburden pressure, which is assumed to be less than or equal to 280 kN per meter square, and n0 is the observed value of standard penetration number, which is given as 13. On substituting this value, the overburden pressure correction will be 13 into 350 divided by 280 plus 70. So the overburden pressure correction will be 13. Next, applying the dilatancy or water table correction, n is equal to 15 plus half times of n1 minus 15, where n1 is the overburden pressure correction. This correction shall be applied only when the value of n1 is greater than 50. Since the overburden pressure correction is less than 15, the dilatancy correction shall not be applied. So it shall be restricted to only overburden pressure correction. So the value of n after applying the overburden pressure will be n1 is equal to 13 only. So option B is the right answer. Question number 73. A direct shear test was conducted on a cohesionless soil specimen under a normal stress of 200 kN per meter square. The specimen failed at shear stress of 100 kN per meter square. The angle of internal friction of the soil in degrees will be. So we have to calculate angle of internal friction. We know that shear stress is equal to cohesion plus normal stress into tan phi. So since it is a cohesionless soil, the value of cohesion is 0. Phi is the angle of internal friction we have to find. shear stress is given as 100 kN per meter square and normal stress is given as 200 kN per meter square. Substituting these values in the above formula, the angle of internal friction will be 26.56 degrees. So option A is the right answer. Question number 74. A footing of 2 meter by 1 meter size exerts a uniform pressure of 150 kN per meter square on the soil, assuming a load dispersion of 2 vertical to 1 horizontal. The average vertical stress in kN per meter square at 1 meter below the footing depth is. So first we have to calculate the total load on the footing. So total load is area into pressure. So the pressure intensity is given as 150 kN per meter square and the footing size is 2 meter by 1 meter. So 2 into 1 into 150. So the total load of the footing will be 300 kN. Load is dispersed in 2 vertical is to 1 horizontal and the size of the footing at 1 meter depth will be 2 plus 1 into 1 plus 1, which is equal to 3 meter by 2 meter. So the size of the footing at 1 meter depth will be 6 meter square. So the average vertical stress will be load by area. Load is total load on the footing, that is 300 kN, divided by total area on the footing is at 1 meter depth is 6 meter square. So 300 kN divided by 6 meter square, which is equal to 50 kN per meter square. So option A is the right answer. Question number 75. A square footing of size 2.5 meter by 2.5 meter is built in a homogeneous bed of sand density 2 ton per meter cube and having an angle of shearing resistance 380. This was expected to give as 38 degree, but there is a printing mistake. The depth of a base of footing is 1.5 meter below the ground surface. Calculate the safe load that can be carried by a footing with a factor of safety 3 against a complete shear failure using Terzaghis analysis. So according to Terzaghis analysis, the ultimate bearing capacity of square footing is given by this following formula and the net ultimate bearing capacity is given by this following formula. So net safe bearing capacity is the ratio of net ultimate bearing capacity divided by factor of safety. So safe bearing capacity is sum of net safe bearing capacity plus unit weight into depth of the footing. So these are the given data for this question. Footing size is given as 2.5 meter by 2.5 meter. Footing depth is 1.5 meter. Factor of safety 3. Unit weight, saturated unit weight is 20 kN per meter cube. Angle of shearing resistance is 36 degree. Since it is a cohesionless soil, the cohesion value C is equal to 0. And for the square footing, these are the bearing capacity factors NC, NQ and N gamma. Substituting these values, the net ultimate bearing capacity is 2532 kN per meter square. Now we have to calculate net safe load bearing capacity, which is given by ultimate bearing capacity divided by factor of safety. So net safe bearing capacity will be 844 kN per meter square. Therefore, safe load bearing capacity is sum of net safe bearing capacity plus saturated unit weight into depth of the footing. So net safe bearing capacity is, so option A is the right answer, 870 kN per meter square. So this completes part 2 questions of this question paper. I hope all the information and detailed solution provided for this question paper is satisfied for your examination preparation and as a reference for other civil engineering competitive exams. So thanks for watching this video. Thank you all.